Yes, ladies and gentlemen, this is teacher Freetoko Victor. Welcome to Gen Z Revamp Chemistry 21st Century Solutions. Today, students, I want us to learn about the different formulas of acids, mineral acids. Of course, we understand that all mineral acids have protons, or they release protons in solution. And of course, many times as students, we have uh, mistakenly quoted that just the formula of a particular mineral acid is written like this, is written like this: HCl, H2SO4, H2, H3PO4, H2CO3, HCl, HNO3, but we don't understand how this formula comes about. But today, their students and their brilliant students, you are going to understand how the formula of hydrochloric acid comes to be HCl, nitric comes to be HNO3. It's not just a matter of this is the formula. Even water, why the formula is H2O, why ammonia is written as NH3. We have many times crammed, and when it comes to exams, we actually don't understand. Oh, when it comes to problems that we need to solve in this new curriculum, we don't understand what we are writing. We just tend to write H2SO4 sulfuric acid. But if you were asked to come up with the formula, just like you come up with the formula of any other chemical substance, would you come up with the formula of a mineral acid? Do you know any fact about these mineral acids? Okay, today I say to you there are two facts that we need to consider if we want to avoid cramming the formula of these acids, uh, to allow us solve problems in our communities, even in like problems that need us to respond to in an examination or whatsoever. One, the fact is all mineral acids release hydrogen ions in solution. Okay, if all mineral acids release hydrogen ions in solution while they are dissolved, maybe probably, that means all of them also have hydrogen ions, because these hydrogen, the protons or hydrogen ions, all of them, they have hydrogen because the ions or the protons come from hydrogen. So take it that all mineral acids have hydrogen atoms in them. And all mineral acids are made up of radicals. Okay, but the type of radical or which radical is present depends on which acid. So your task is to identify which radical is present, because obviously they all have proton, hydrogen, H. Because the first step in coming up with the formula is to identify which atoms are present, or which atom with which radical, yeah, present in the particular chemical substance. Now, in the context of these mineral acids, we all know from that fact hydrogen is there. So we have H automatic. And then if we look at nitric acid, from the word nitric, you can sense that there's nitrate. Okay, you can as well take it that in nitric acid we have nitrate, if not from the sound of the name of the particular acid. Take it that nitric acid has nitrate present, but also from the sound of the name nitric. Okay, meaning nitric acid has hydrogen and nitrate. The rest of the procedure of coming up with the formula remains. The valences. You write the correct symbol of the radical and the and the hydrogen. Then you look at the valence of the radical and the valence of the hydrogen with the normal procedure of getting the formula of any other chemical substance. That's why nitric acid, hydrogen has valence 1, nitrate has 1. Nitric acid, when the valence is intermarried by the opposite atom and radical, we have HNO3. Okay, sulfuric acid is, of course, we have hydrogen. That's the first atom. Then sulfuric, we have sulfate in sulfuric acid. That's the radical. And of course, the combining power or the valence of the radical is equivalent to the charge that the radical carries. We have cationic radicals. Those are positively charged radicals. Then anionic radicals. Those are negatively charged radicals. And of course, their valences or the combining power is based on how the number of charge of the radicals. Sulfate is written as SO4 2 charge of 2, that is as a radical. But when it's in a compound, the charge is ignored. So it has a valence of 2 because the charge is used there to combine. So you don't write it independently. Yeah. So now we have HSO4. The valence is 2 for the sulfate, 1 for when they intermarry. Then you have H2SO4. So there, students, this is how you can come up with the formula. Just be a matter of identifying the atoms. And of course, for acids, the atom, one atom is a radical, one is a proton, that is hydrogen. Of course, radicals behave like a single atom, but they are polyatomic mostly. And they are monatomic radicals like chlorides, fluorides, iodides. They only have one atom in them. Yeah, but they behave as if they are only a single atom for those which are polyatomic. So carbonic acid has hydrogen and a carbonate. Yeah, that's why with the hydrogen and the carbonate combined, the carbonate has valence 2. We have H2SCO3. CO3. Water, we all know water has hydrogen and oxygen. Don't think that the formula of water is just H2O. Yeah, the issue of just H2O, not know how it has come. No, water has hydrogen and oxygen. Yeah, that's why hydrogen having valence 1, oxygen has valence 2. The valence is intermarry. That's why water is H2O. Ammonia, adding nitrogen and the hydrogen. Nitrogen has valence 3, hydrogen has 1. So the nitrogen transfers its valence to hydrogen. That's why hydrogen having 1 transfers to nitrogen. So it is ideal any1 H3, but writing the 1 is similar to not writing it. That's why it is any H3 for ammonia. Thank you so much, students. Your role in coming up with the formula of a substance is to identify which radicals are present in this. For acids, please, we have protons and a radical. Your work is to identify which radical is present because all of them have hydrogen. Yeah. Thank you so much. Follow me in YouTube, Bush Lawyer Uganda, teacher Freetoko Victor, for more lessons in chemistry. Enjoy your chemistry with 21st century problems for 21st century solutions. Thank you so much.